right, so I want to invite on the stage our next speakers. Yeah, please take it away. Give them a hand of applause.
As a kid, I had a game that I really liked, and it was hide and seek. It was so much fun.
Of course, hiding and seeking is a lot of fun. How about we do it in the office?
In
or
the office?
Maybe conference?
Come on, Misko, let's be serious. Okay, you don't want to do that with search engines, right?
Yeah, I know they have. If you have a huge bundle sizes, search engines can't search you, and then you're hidden from them. Why would you do that?
Yeah, okay, I got it. So you're talking about the wombats, right?
What?
Yeah.
Wombats?
Wombats, the NPM mascot. You invite one, and then you got the entire family showing up.
Oh, okay. I see where you're going.
Okay, next question might be, what about families? Well, it is kind of a family gathering, right? We're here at NGBE celebrating Angular and the Angular community. Why family? Also because, well, Twitter says so, right? It is Papa Misko. We all know Papa Misko because he's the father of AngularJS, the father of Angular, and also the creator of Qwik. Today, Misko serves as the CTO of Builder, and Builder is building an amazing product, a visual headless CMS. The idea is simple. Your developers, your development team will create components that the marketing team can then drag and drop within an editor to create web pages. The other thing I like about Builder is the people behind this open source project. And one in particular, Partytown, is really useful when you want to perform well on SEO, because it will allow you to take some code, okay, that is supposed to run on the main thread and put that in a web worker. So think about it. The mental model you can have is really like you take a wombat away and you put it in a web worker.
I like that. That's a good way of putting it.
That's a good way to put it.
Well, let me introduce Antoine Pairet here. He's a CTO at Rosa, and he also has a pretty good experience. So he started his career with building a web application for his wife, who's a dentist.
Yeah.
It was an AngularJS application. Then his dad was a general practitioner, and so he built an Angular application to manage the practice. And finally, he's moved on to building a booking application for the patients on the web, and that actually is done in the mixture of AngularJS, Angular and Qwik.
Exactly.
And so I'm going to let him tell the story here, and then I'll come back later.
Thank you, Misko. So at Rosa, what we want to do is to really simplify healthcare. We want people to use a health application to basically manage everything on their smartphone. But to get there, you can't ship an app like that. Okay, so we decided to start with appointments. And so we have a calendar application that will be used by health professionals. So you have health professional on the side with a B2B application. They open the app in the morning, they use it all day long, and then they close it at the end of the day. When it comes to SEO, you don't want to kind of have your app score high on SEO, but you want a marketing website promoting your app to score high on SEO. But then the second part is used by patients. And there it is a B2C application. And there you actually want your app to show up in the search results. You want that when a patient is looking for a dentist in Brussels, that search entry scores high. And so in one case, you have a very small number of pages. You have very little interaction. And on the other hand, you have a lot of pages, and they are fully interactive. So we're going to check, I'm going to share the story of how we built that marketing website using Angular and ask the question, how can we, or does it scale to do something like that for a real application? So we do use NX. We have a monorepo. And of course, we use a design system that will kind of provide components to different applications. So we have our design system here. We have the health professional calendar application there. And then the idea is, hey, could we reuse that same design system to create the marketing website? And because you create a marketing website as mostly static content, and so the first thing that you do is to say, hey, let's do SSG or SSR to improve the user experience and load things faster. But you still have, you still require hydration to provide interactivity. Okay, so you still pay that cost. Let's have a look at that marketing website. What type of interactivity do we have? It's very limited, right? As like when you scroll, you show a shadow. When you have tabs, you have tooltips, you have drop downs. And so the question is, do we really want to load, have all those wombats come into the browser? Do we really need the Angular runtime to be there in the browser? And so what we said was, okay, let's try something. We're going to have a build step. We're going to have 2 steps in the build. In the first step, we're going to server generate all those pages. And these HTML pages, static pages, are going to have that script tag trying to load Angular. And what we're going to do is to strip that script tag and inject another one with purely vanilla JavaScript implementation of these small interactions. And so on a wombat scale, right, this step here with the Angular bundle is quite heavy. And on a wombat scale here, that bundle with JavaScript is little, it's very light. So if you check that, how we do it actually, so we have components in the design system that are coded twice, and the interaction is coded twice. So first in the Angular components, because they can be used across the monorepo by different applications. They will be used when the server is rendering or generating those pages, and in the other real applications. And then you code it the same thing a second time for the sole purpose of having that interactivity show up when you don't have the Angular runtime shipped in the browser. So you avoid having like the entire Angular runtime. You avoid having your destructive hydration. Now, if you look at what you load in the browser, so you have all these little features here, loading those different implementation in pure JavaScript. What we basically have is like kind of non-destructive hydration, right? So in the browser, you're attaching your event listeners, etc., without destructing your DOM. It's basically close to what jQuery was back in the days, right? The cool thing is you can really have good web core vitals with that. Okay, so if you look at that, those scores are quite great. And the only reason why we don't have 100 is because we didn't use NGS or C to optimize the images. We should have known better. So if you want to build a marketing website, that technique works. But what about something like a real application? And so here you can ask yourself, okay, what does that mean? What you need is to scale across 2 dimensions. First, when you go from a marketing static website towards something like bigger, you might have hundreds of thousands of pages. You might have 1 million pages. Then you want to add more interactivity. You want this to be a rich and beautiful application. The question of scaling in terms of number of pages is the easy one. Because even if at some point in your CI system this takes too long, you can switch back towards SSR and you don't have a long CI. So number of pages, it is taken care of, it's okay. But what about interactivity? When you think about it, we have something that is super simple, and yet we have quite some code. Any idea how much code we ship, if you had to guesstimate? Misko, maybe?
19.3 kilobytes.
Oh, he is good, he is good. Exactly 19.3 kilobytes of JavaScript. And when you think about that, we have like huge trade-offs, huge disadvantages, okay? We have to code the same thing twice. Then you do not have any component communication, you have no shared state, no nothing. And yet, if you want to do something more evolved than what we did, you will have to ship a lot more JavaScript than that. And then, if you again use that wombat scale, you will see that the size of your application code is way more important than whatever framework you would use. And so it does not make sense. You're kind of stuck. Going down that road is not worth it if you do not have lazy loading. It is not worth it if you don't have a bundler that understands how to split your code and to be able to lazy load only part of that. So we're kind of stuck. We don't know what to do. But there must be a better way. Misko, there must be a better way.
Is that my cue to get up? Thank you. So, let's see. Yes. So let's talk about resumability. And so the first question is, what is resumability? And so that goes back to, I don't know if some of you remembered, I like to make up words. I made up this other word called transclusion that Shai has made a lot of fun of me for. And so now I made up a new word called resumability. So let's kind of dive into it. So I think the resumability really comes down to virtual machines. The first time I saw a virtual machine, I was really blown away. Because you would take your physical host machine, and inside of your physical host machine, let's say it's a Windows, you would boot up Linux. And you would actually, in the window, watch the boot up process. You would see the BIOS coming up, you would see the boot up process, all the drivers loading, everything. And eventually, a login screen comes out, and then you log yourself in. And then you open up a word processor, and you start writing a letter. And at some point, you can take the virtual machine, and you can save it into a file. And this is where the mind-blowing part comes in. You can take that file and send it to your friend. And your friend will open that file up in their virtual machine, and they don't get to watch the boot up screen. They don't get to watch the BIOS or the drivers loading or the login screen or opening up the word processor or typing the letters. They literally open it up exactly where you saved it with the cursor blinking at the next character for you to start typing. And that's what fundamentally resumability is. Now, you change the file to an HTML, and you change virtual machine to a server, and the other virtual machine to a client browser, and now you can do the same exact thing for a web application. And so I always talk about hydration being like a workaround and resumability being the solution to this particular problem. So let's talk about hydration for a second and why I think a lot of applications are having a hard time getting a good Core Web Vitals score. So you start with HTML, and the way it normally works is that the HTML just has a blank page, right? And so you don't see anything. And then inside of this blank page, there is a script tag that says download a JavaScript. This JavaScript executes, and it eventually starts rendering the page, and the page gets rendered, and finally, you have a page on your, in front of the user. And there is a delay between the white screen and the page that the user sees, and this delay is usually problematic. And so at this point is when the user can kind of interact with the page. And so a lot of people see this, especially in e-commerce or marketing websites, and they say, this is a problem. This isn't really working for us, right? It has two problems. One is that the user gets to stare at the blank screen. And the second problem is that the search engine doesn't get to see anything. The search engine literally sees a blank page, and so you don't really get indexed. I know there are ways to kind of get around this particular problem, but fundamentally, it would be better if that white page wasn't white and was actually filled with the actual content. So people looked at this and said, you know what, I know what we're going to do. We're going to start doing something called server-side rendering or pre-rendering or server SSG. There's a lot of different names for it. But the basic idea is that we take the HTML and now we make it bigger. And it's bigger because we included the application, the rendered application in it. And so when the HTML shows up in the browser, it shows up ready to go, right? The problem is you can't click on it. This is not interactive. It appears faster, but you can't really do anything. And so that rendered application then goes and downloads the JavaScript. Then it executes the application, and then it does render, which goes and literally just replaces the DOM and puts the DOM to what it was before. And then people kind of realize, well, we can do better than that. We can reconcile, which is just a fancy way of saying, let's resume the DOM instead of throwing it away. But fundamentally, you can think of it as literally just replacing it. And it is at this point that the application is interactive. And this is where you can click on it. And notice something funny. It appears faster. It's actually slower. Because now we actually have to send more HTML. We did everything we did above, plus the HTML payload is bigger. So we actually made the situation slightly worse at the illusion that it's actually better. And so this is what hydration is. Now, the reason it's kind of worse is because now we have duplicate information. If you think about it, the content that's in the HTML is also the content that's inside of the JavaScript. The same information is present twice in two different formats, once in the JavaScript, once in the HTML, but it's the same information in both places. Okay, so what is resumability? So hydration's on the top. Resumability goes slightly different. So again, we start with the HTML, and then we show the page, just like before, but this is the point where it's interactive. And it's interactive because resumability knows how to save listeners directly into the HTML. And at this point, the system says, yes, but I'm actually faster. You can interact. So this is not just appears faster. It actually is faster. And then you go and start downloading JavaScript because the user might interact. Now, at this point, you say, yeah, Misko, you're cheating. The box on the bottom is smaller than the box on the top, right? Like, that's a smaller box. Like, if you make it look like it's better. Well, that's because we removed the duplicates, right? Resumability can figure out basically that piece of code only executed exactly once, and therefore there's no need to send it on a client. And so many of the duplicates can be removed. So because we don't have any of the code, it turns out we don't need to execute the app or reconcile, and that's basically what resumability takes care of. And so, you end up with basically this outcome. And this is what resumability is. Now, the question is, which frameworks are resumable? And so, there's a framework I work on right now called Qwik. eBay has a framework called Marco. But I shouldn't forget an important framework that you all used, you just don't know about it. And that's Google Wiz. Google Wiz powers Google Search, powers Google Photos. And one thing you can say about Google Search, it is blazingly fast, right? It is impossible to get to the situation where you want to interact with Google Search and Google Search is not ready. That thing is always ready for you, right? So that's the technology behind that. It's Google Wiz. Unfortunately, it's not open source, but it is a framework that's been around for a pretty long time, about 10 years or so. So the question I have is, can Angular join the group? And I'm looking at Pavel over here in the front. So let's talk about this. Now, the first thing we need to talk about is coarse-grained reactivity. And what's coarse-grained reactivity? It's basically how Angular works today. And that is that imagine you have a buy button and a shopping cart that's far apart, and there's some components in between. And because the buy button and the shopping cart needs to talk, they need to share state. And so the shared state would be at the the closest common ancestor that is shared between both of these branches, something like this. And so what happens now is that the state kind of flows down, right? And whenever you click on a button and you need to re-update the shopping cart, the whole thing has to re-render. And when it has to re-render, that means all of the code has to be present. So all of the hard work you've done in terms of resumability to make sure that like the unnecessary code is not present, all of that hard work kind of goes out the window because you need to download everything now again. And you can do tricks. You can mark certain branches as no need to update. But that's extra work. Most people don't do that, right? By default, everything re-renders. And you have to kind of go in and opt out and kind of mark certain branches as not resumable. But even so, even if you mark everything, you still have a header and a user that's kind of in the way, in the middle. And so what you really, really want, is to just update the shopping cart in it. So coarse-grained reactivity causes most of the application to re-execute. And the execution is not really as much of a problem in terms of performance as from the fact that it makes it so that the code has to be present. And that's the real problem, right? Is that it forces the code that isn't really needed to be in the browser. So fine-grained reactivity and signals. Now, this is where I'm excited because Angular is adding signals, and signals are a step in the right direction. And I'm super excited about this because this is what gets us closer to resumability. So before we do that, let's talk about signals. So signals, we have basically values. Values is just, let x equal 42. That's a value, right? There's nothing special about that. A signal is a value, but it's in a bucket or a box. It's in a container. And then observable, like I'm sure you're familiar because you're an Angular developer, is a little more complicated data structure. But the thing over there is that observable are values over time. And the word time is super important to observables. And it's important because it means that values show up over time, but more importantly, it means that you can't really look into an observable and say, what is your current value? That's kind of like, observables are like events that are coming out of the browser, like click events, right? To ask a question of like, what is your current click event makes no sense. The click event either already showed up and it was processed and it's gone and there's nothing to talk about, or it's going to happen in the future when the user clicks on it, but there is no current click event. And that's kind of in the stark contrast to signals where you talk about the current value that is in the box. And I think a good way to look at it is how do you declare it and how do you read it? So the way you declare a value is you just say const answer equals 42. The way you read it is you just kind of read it. Like that's easy. Like that's pretty straightforward. With signals, we take it to 42 and we have to wrap it inside of the box. And so that's where the signals comes in. And then we have to kind of get it out of the box somehow. And this is done a lot of different ways. In Angular, this is done by just calling the function that represents it. And that function is a getter. And it basically allows us to return the value that's in the box. And the thing that's nice about it is that when you ask for the value in the box, the framework says, aha, you're interested in this value. I'm going to make a note of that. Because that means that at sometimes in the future, I might have to notify you again that this is probably outdated and you should probably look into the box again for the new value. Whereas if you look at observables, you have to have a subscription and you have to have a closure that you pass in, right? And so what's happening here is that a signal is a pull-based value. You can reach into it and pull it out of the box at any point. Whereas an observable is a push-based system, right? Observable pushes the value to you and says, now, process it now. And so while a lot of people like to argue that signals and observables are really the same thing, I think there is an important difference that you should kind of point out. And it really, to me, comes down to the kind of the subscriptions. So I kind of made a table here kind of comparing these concepts. And the point here that I'm trying to make is that a signal is a container of a value versus observable is a container over values, plural, over time, right? The next line talks about time and how there is really no concept of time other than inside of observables. That's when time matters. Everywhere else, the time does not matter. You know, accessing the value is either a direct through getter, which is a pull, which is pretty straightforward. You know, like mentally you're thinking about, I'm going to do this, then I'm going to read the value, then I'm going to do this other thing, and so on. It's a straightforward mental process. Whereas with observables, it's kind of upside down. It's push, right? Like the observable says, you give me a callback, and when I'm ready, I'm going to call you. And so it's kind of a push thing. Subscriptions are also kind of interesting because subscriptions in observables are explicit, means somebody somewhere has to call subscribe. Signals don't even have a subscribe method. There is no explicit way you can subscribe to it. Instead, signals get subscriptions implicitly by you calling a particular property and reading it out. The other interesting bit is that signals are fundamentally synchronous, right? You read them synchronously. You get called back synchronously when things change. Like if you're computed, it's a synchronous operation and so on. Whereas observables are kind of a mixture of hybrid world. Like they can't be synchronous. They can also be asynchronous. It is definitely not something that you can say it's always synchronous. Sometimes it is, sometimes it isn't. And finally, what I find super interesting is the way you use observables is you usually set up a graph. I think of observables as a pipes. So you wire the pipes together, you know, connect all the fittings, and you get some kind of a graph going. And once this graph is kind of set up, for the most part, it doesn't change in the application. Like it could. There is API where you could change it. But the way most people use it is that the graph is fixed. Whereas with signals, the graph is very dynamic. As you use signals, you can subscribe to different things just by reading it. And over time, you can then, next time somebody calls you, you don't necessarily read it because you take a different if branch, and now the subscription is removed. And so it's a very dynamic system. And so if you go back to our original application, like this, the thing that I really like with signals is that they allow you to, when somebody clicks the buy button, you get to go directly to the shopping cart and say, hey, you're out of date. You need to re-render. And that's what signals enable. And so the most exciting part of it is not necessarily that it's faster, which is true. It is faster. But I think the thing that I always tell people is it doesn't matter which framework you use. They're all fast enough, right? That's not really the reason here. The nice thing here is that because all those other bits do not execute, that means it's the code we never have to download. And if it's the code that we never have to download, then your application becomes smaller, lighter, more nimble, and better for SEO. So fine-grained reactivity really allows the framework to be surgical about the updates, and the thing that it makes this possible is that you don't have to download a whole bunch of code. Now, there is a little tiny problem that Pavel needs to solve. Sorry, Pavel, for putting you on a spot here. Okay, I love the work you guys are doing in Angular team on signals. I really do. I'm super impressed. I love it. I cannot say enough good things about it. Here's the problem. In order for the signals to build up the reactivity graph, the whole application has to be executed from top to bottom at least once at the very beginning. Do you see the problem? We fought so hard to make sure that we don't have to bring unnecessary code in, but in order to initially have the reactivity graph, we need to execute the application from top to bottom at least once. After that, we can do amazing things. But the first time, we have to do it once from top to bottom. And this is the problem that kind of needs to be solved so that Angular can have resumability. But I think it's a solvable problem, and in good hands of Pavel and the team, I'm sure that it will get solved. I'm sorry, Pavel. It's just so much fun. Yes, we will have a conversation afterwards here. So if you can figure out how to see, the thing is, this application already executed on a server as part of SSR. And while it was executing on a server, you got to observe all the signals, you as a framework. The framework got to observe all the signals. And because all the signals were observed, the framework knows at the server what the reactivity graph is. If only we could somehow serialize this particular reactivity graph into the HTML, then on the client, we can resume where we left off, and we don't need to download those white boxes because those white boxes are components that don't actually do anything and don't need to be re-rendered. And so that's the challenging part that needs to be solved. So the problem here is, again, it's not about that signals are faster. Yes, signals are faster, and because they're fine-grained reactivity, and yes, that's exciting. But the real value here is they allow you to not download a whole bunch of code that normally has to get downloaded. So serialization of reactivity graph is the magical thing to solve, and then Angular can be resumable. And I think resumable is a cool property that I think a lot of frameworks of the future will have. And I love the fact that the first check mark is already there. Good job. On to the next one. So how can you integrate Qwik into the existing ecosystem? So Antoine, do you know anything about this?
Let's see. So you got me excited now about resumability, right? But let's be honest. We do invested a lot in our applications, and you don't want to throw that away and say, let's start over and rewrite everything in Qwik. So how can you leverage Qwik today within existing ecosystem? Well, if you're in the React world, it is quite simple. You can use a function, Qwikify, that will transform your React components, and it will return a Qwik components that will act kind of like an island. And from there, you can compose and build your application. But that does not exist when it comes down to Angular and Qwik, at least not yet. Maybe when they get closer together, after they have like signals and the reactivity graph, etc. But so how can you do that with Angular and Qwik today? So at Rosa, we've been using Qwik in production since October 2022, since last year. And we've been doing two things. And so the first one I want to show here is we had a new application. And so we started building that application in Qwik. But at some point, we wanted to reuse existing components and integrate them within the Qwik application. Maybe because these components were too complex or too long to be rewritten, or just because we wanted to keep them in Angular. We don't know. And so here you have the Qwik application. Okay, this is the first page, the first part of that Qwik application. And you can think about it as an input field you search for a specific health professional. And then at some point, you find that Dr. Awesome. And Dr. Awesome has a public page. You load it. And on that public page, a patient can interact with what we call a booking widget to find a spot to book an appointment. And so that here, the booking widget here is written in Angular. It's a more complex or advanced component that we embed into an iframe into a Qwik application. And from there, you can continue on another part of your application where SEO would matter less. Okay, think about it as when you try to find Dr. Awesome on the internet, you want to score high on SEO, right? But when you have the confirmation about that appointment, it does not really matter in terms of SEO because you're behind a login screen, etc. That is not something a search engine can crawl. So in that case, you have a Qwik application that is kind of the host to another Angular application, and you can communicate between the Qwik and the Angular application using post messages. The other thing that we did was we had an Angular application, and we started to rebuild it step by step using Qwik. And so the idea is to say, hey, let's not do a big bang and work on Qwik for like 6 months, a year, and then try to replace everything. Again, it is like, hey, let's take step by step, think step by step, and first implement the pages that are more important, and then maybe the rest can be left using Angular. And so that is something you can do if you put a proxy in front of your application, and that will decide what page or what framework should be used for what page. Okay, so you can do that using Nginx, you can do that using CloudFront, whatever. Now, the thing is, this only works for applications that do not share state, right? Where the state is not like persistent between pages. Or if you can serialize that state and put that in the URL, for example. Because the application in Qwik here doesn't know that the Angular application exists. And the Angular application doesn't know that the Qwik application exists. It is the CloudFront in front of it that is deciding what to load. Okay, so here, first URL, load the Qwik one. Second URL, load the Qwik one. Third URL, load the Angular one. Now, you might ask yourself, yeah, what about navigation? Because once you're into the Angular application, you're kind of trapped within an SPA. So how can you get out of that SPA and go back to the Qwik one, to the SSR one? Well, you can use a small trick to do that, and you can use a can activate guard so that you will force the reload of the Angular application in such a way that, because you're forcing the Angular application to reload, then it goes back to the proxy and goes back towards the Qwik one. So that when you're on page 3, you hit the back button, you load page 2, and page 2 says, can I activate? Oh, no. You have to reload, and then you go back to CloudFront and back to the Qwik application. All right? Good. So what are the benefits here? So let's start at the very bottom. So here we have the Angular part. And that Angular part is not optimized at all. So we didn't do anything. We didn't try to SSR it. We didn't try to lazy load stuff, etc. We just used Angular out of the box with an SPA like that. And the score we have in terms of Lighthouse is kind of disappointing. We want to do better. We want to have better SEO and better web core vitals. Now, if we take one step, look at the second part here with the Qwik container with the Angular most advanced booking widget, then we do have an improvement in terms of performance, which is good. If we look at the Qwik, the part which is fully in Qwik, then out of the box, and that is the crazy part, it is out of the box. You do not have to do anything. It comes for free. You have 100%. For free, without any optimization, you got something that is close to perfection in terms of web core vitals. If you look here at results for Rosa.be on a fast 3G connection, you see that you can have a first contentful paint of 0.7, and you can have the largest contentful paint at 1.82. And in fact, when you think about it, the difference between the first contentful paint and the largest contentful paint, the difference between these two is not linked to JavaScript. In our case, it is because we start to load some SVGs. But if we inline these SVGs directly into the HTML, we would have something like 0.08 for the first contentful paint and the largest contentful paint. Okay, so it is not a JavaScript problem any longer. It becomes an optimization of images, etc. It's a completely different story. Okay, so I think we got a bit more time. So I want to show you two things. I want to insist on the fact that resumability is different from hydration. That's the first thing. And the second thing is I want you to remember that Qwik is not about islands. Okay, so I'm going to steal a demo that Misko did. Okay, so it's not me, it's all Misko. If it doesn't work, it is Misko, right? So here you have kind of a, you want to zoom in? Yes. Oh, like that? Yes, yes. Better. Okay, so let's look at a monolith application here. And you see that there are different steps, right? The first one is SSR, and then we're going to get going. Okay, so you got the SSR HTML. It's sent, you download the JavaScript, your browser executes all the code, and then you got your application, which is like interactive. And so you saw that we basically sent a screenshot to the, it's like if we sent a screenshot or the DOM without any event listeners on it, it's not interactive. And then after downloading, executing the JavaScript, then your application becomes interactive. That is how SSR will work. Now, imagine that you lazy load a monolith. So you do the same thing as both, but you do have some lazy loading. So the browser downloads the application JavaScript, it executes, and then, because it's some part of it will be lazy loaded, you only execute part of your code, right? And then, at some point, the framework will request the lazy loaded components because they become visible, and then it will kind of complete the rehydration of the application, right? Now, let's continue. In the case of islands, for example, so the Astro, so you directly got something, okay, that you can interact with. But the thing is, let's have a look if I interact with one of these components. If I click on that component there, what will have to be hydrated? Oh, that entire group. Okay, so you need to hydrate, you need to download, you need to parse all the JavaScript code that is needed for that entire part of your application. It's big. Now, let's do the same with something that is resumable. I'm going to click on one of those, on one of the parts of this application, and let's see what becomes blue. If I just click here, in fact, I might only have that single component here kind of resume, and because there's a dependency with one other component, then that other component might also kind of resume. Now, there's one thing that this demo doesn't show, is that here we are talking about components, but Qwik and resumability gets further than that. It can say that only a click handler should be downloaded and kind of resumed, and not an entire component. And so when you think about what resumability is, or is Qwik island architecture? No, it is not, because the island will be at orders of magnitudes above what Qwik is able to do. So island, application, components, component tree, and then kind of interactivity, while Qwik is directly at the interactivity, at the click handler part. Good. If we go on Rosa.be, that is how fast it loads. You didn't see any, you didn't wait for anything, it's instant. And if you had to guess, Misko, because I know you're good at that, so if you had to put that on a wombat scale, how much do you think we ship to the client for a fully working application?
I should know that, but I forgot.
No, close to that. So we have 30 kilobytes of JavaScript full stop. And you know what? We have 30 kilobytes, and about a third of that is for performance tracking, etc., because we load a third-party script. If we take that script and put it in Python, we would have 60% only of that, I would say, load that we ship to the browser. And that is crazy, because you have, with a tiny HTML page, directly something that is fully interactive, and your users can directly interact and play with it. Okay, so today we've seen a lot of these, I would say, improvements and innovation that are happening right now in Angular. And I think Misko highlighted like different also the work on signals, etc. And it is super exciting. And with the improved SSR pipeline, with the SSR standalone component, with partial hydration, etc., non-destructive hydration, the example that we showed today with Rosa, with Qwik and a V15 Angular would be even better with a version 16 Angular. So it's quite exciting. And also we have like Angular and Qwik getting closer together. And I have one wish for the Qwik community, and it's for the Qwik community to be as welcome and as family friendly as the Angular community. Thank you.